All right, so we want to figure out what intervals this function is increasing or decreasing. And so what we need to do is study the first derivative. So we're going to calculate the first derivative, find critical value. So find where the first derivative is 0 or undefined, break up intervals at those values, and see what's going on in those intervals. So let's first calculate the first derivative. I'm going to rewrite this actually. Remember, this is x to the 1/2. So x to the 1/2 times x, so I'll just be x to the 3/2 minus 3 x to the 1/2. We'll see if this is easier to differentiate. So h prime of x will then be 3/2 x, the 1/2, minus 3/2 x to the negative 1/2. This is the power rule. All right, so now we want to find where this is undefined or where it's 0. So it's h prime of x is undefined for remember, this will be undefined when, let's rewrite this actually. Let me write this as 3 halves times the square root of x minus 3 over 2 square root of x. Then you can see that the x is in the denominator here. It's undefined when x is 0 because you're going to have it, 3 over 0 here. But we already restricted our domain to be more than 0. So there's nothing in the domain that this will be undefined for. So we're okay. So then I cross that out. So now let's find where is h prime of x equal to 0. So now we want to find the zeros of this function. So let's set this equal to 0. So we're going to have 0 is equal to 3/2 times the square root of x minus 3 over 2 times the square root of x. And then we solve this. So let's add this to both sides. We can factor out the 3/2. So we'll have 3/2, 3 over 2 square root of x is equal to 3 over 2 times the square root of x. These, again, we can cancel out these 3/2. This is an algebra problem. So we have 1 over the square root of x equals the square root of x. So when does this work? So we multiply both sides by x, or the square root of x. So let me just show you. Okay. Multiply both sides by the square root of x. That goes away, or that doesn't go away, but it becomes 1 is equal to just x. Square root of x times the square root of x is just x. So here's our critical value. Critical value is x equals 1. And that falls in the domain because that's greater than 0. So now we make I like to make a table broken up at this point. So what I mean is I have my top row be my interval. And so I go from negative infinity to 1, and I go from 1 to infinity. Actually, no, not negative infinity to 1. I'm going to go from 0 to 1. That was let that be a lesson to you. You always pay attention to this. So from 0 to 1. 0 to 1, then 1 to infinity. And let me test the value in there. Test the value, test point. Pick any x value in here. So x could be like 1/2. Here it could be x is 2, let's say. Doesn't matter. And then I want to evaluate the first derivative at these x values. I want to see what's going on with f prime of x here and here. And I really only care about the sign of it. Yeah, if you get the exact value, that's good. But don't spend too much time on, a tedious calculation, especially if you're doing it during a test. Just focus on getting the correct sign for this, whether it's positive or whether it's negative, in other words. So let's say I take f prime of 1/2. So I plug 1/2 into this equation here. or not, well, yeah, well, 1/2 in this equation or here, any derivative equation. So you actually work it out over here. So f prime of 1/2, and this is a good example because you can see this will be like a tedious calculation. You're going to have 3/2 times 1/2 of the 1/2. So you got basically 3/2 times the square root of 1/2 minus 3/2 times the square root of 1/2. Interesting. So you want to basically figure out what this value is, see if it's negative or see if it's positive. Now, actually what I can do is you want to make the first derivative equal to 3/2 times the square root of 1/2 minus 1 over the square root of 1/2. You can do that, but it doesn't really matter. Just use your calculator here. You know, don't spend your precious time on this. So let me go calculate. Now what I get, rinse my calculator. And again, don't worry too much about the exact value, just worry about the sign. I'm going to get that this will be about negative 1.06. What I care is that this is negative. Negative. So I'm going to put the negative here. Oh, that's what I care about. Now let's see what f prime of 2 is. I want to see if it's positive or negative. So f prime of 2, just plug the 2 into the second derivative equation, or in the first derivative equation. So f prime of 2 would be 3/2 times the square root of 2 minus 3/2 times the square root of 2. I'm going to run it in my calculator right now. I'm going to get about 1.06. Positive 1.06. Oops, positive 1.06. Positive. So then I'm going to put positive. Now, if you're worried about like, well, if you don't have a calculator in your test, you can't do this. Well, if that's the case, pick a value that's easy to take the square root of. That's in this. It's in each interval. So like, and a number that's easy to take the square root of in 1 to 1 and 1 to infinity will just be like 100. Take 100. You know. And here you're like, well, just take like a fraction. Take like a 1/4 or something. But usually on tests, you're not going to get calculations that are tedious like this because that's not where they're testing. Like on your AP exam, you're going to get calculations or problems where the calculation works out easy by hand. It's not going to be a question of whether or not you could do, some tedious algebra. So don't worry about that. But anyways, so it's the first derivative is negative here and positive here. And so what that means is that the function is, let me draw on the next line, f prime of x, or not f prime of f of x. If this is negative, first derivative is negative, that's telling me that the function is, I was going to say decreasing, I drew upward. It's decreasing, that means it's going downward. Like that. I like to draw a little symbol just to get the idea. If the first derivative is positive, that means the function is increasing. And that's all we're basically trying to find here. If you were trying to find, a possible extrema, you can see that there would be a relative minimum here, but we don't have to go that in this problem. So we just summarize that f of x is decreasing on 0 to 1 and increasing on 1 to infinity. There you go. That's all there is to it.